So now, because you've got those substitutions memorized, you know that if I see x squared minus a squared, you're going to use the x equal a secant theta. So this is x squared minus 1. So the substitution I'm going to use for this particular problem will be x equal 1 secant theta. So then dx is secant theta tangent theta. Okay, so the most common mistake is either to forget to find dx or put it in. So right now I'm just going to put it in. So secant theta, tangent theta, d theta. Okay, so we've got this x in the denominator. So that's like secant theta right there, right? Because that's what x is equal to. And then here comes the radical. Now remember, the reason we're doing this is because inside the radical will be an identity. So if I put x squared in, I'd have secant squared of theta minus 1. Wait a minute, you know that tangent squared of theta plus 1 is secant squared of theta. So that means secant squared of theta minus 1 is tangent squared. So I'm just going to go slow here. So this gives me tangent squared inside the radical there. There's my secant. And then here's secant theta, tan theta, d theta. Okay, let's start canceling, right? And then this gives me a tangent. The square root of tangent squared is tangent. So I have a tangent times another tangent, and then I get tangent squared. What do I do with that? So I can't do any peeling or anything. Oh, right. This is where we use the identity. So again, using this identity, tangent squared theta is equal to secant squared theta minus 1. I just substitute that in. Secant squared theta minus 1 d theta. Now I'm going to take the antiderivative, so that's tangent of theta minus, and be careful, the antiderivative of 1 is theta because it's d theta. All right, so now I need the triangle to get it back to x's. So the triangle comes from this. So let me just write it down here. X over 1 is secant of theta, or you can think of it as 1 over x is cosine of theta, however you want. So I make the triangle. So I have adjacent over hypotenuse, or hypotenuse over adjacent, either way. Fill in the third side, which should make you feel good because this should be the expression, right? This squared, subtract this squared would be the third side. That's the expression that was in my original problem. So a little bit of a happy moment there. Tangent theta would be opposite over adjacent, and then over a 1, and then subtract off. I have lots of different ways to find theta. So I could find theta by taking the inverse secant of both sides, or I could find theta by taking the inverse cosine of both sides of that. Either way works. It really doesn't matter. So I'm just going to use this green one. So I get the inverse secant of x plus c